We have three problems here put together. So number 14. So we have a single molecule. Okay, so a molecule has this really tiny mass, and we want to know the molar mass. So when we think of our units on that we're given here, we have 5.56 times 10 to the minus 22 grams per molecule. Okay. So what we want molar mass. Molar mass equals grams per mole. If you want an answer where you have two units, we have two units in the final answer, it's easiest if you start with 2 units in where you start. Okay? And you start with them with hopefully one of the units, in this case grams, in the right place. So that tells you if you're upside down or not. So we have grams per molecule and we want grams per mole. All we have to do for this is convert the bottom one, go from molecules to moles. Okay. One other tedious thing, 3 sig figs, so that's how many our final answer is going to be. There's 6.02 times 10 to the 23rd molecules in a mole. And so if we were just to multiply that out and finish that, we should get 335 grams per mole. You get something a little bit different, but then when you round to have 3 sig figs, you should get 335 grams per mole. All right. Now we have this crazy formula. It tells you all this stuff. Some die, blah, 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 blah. We have 2 times 10 to the 12th molecules. And it wants to know how many grams is this. Okay. So this is that whole mole island thing. We're going to go from molecules. We have to go to moles, because we almost always go to the island. We get on our molecule boat, our Avogadro number boat, and then we're going to go from mole to mass. We're going to get on the mass boat using molecular weight. So this one's going to use Avogadro's number, this one's going to use molecular weight, and so we have to go through mole island, okay? 1 sig fig, so our answer is going to have one significant figure. So 2 times 10 to the 12th molecules. Okay, we're going to go to moles. So that's just times 10 to the 23rd molecules per mole. And then for this thing, the big thing is figuring out what its molecular weight is. It's 879.8 grams per mole. Okay, so you have to figure that out. So 1 mole is 879.8 grams. All right, we are now in grams. How many grams? We're done. So this divided by this times this. 1 sig fig. 3 times 10 to the minus 9 grams. That's the answer. Okay. Last problem in this set. Humalone. Okay. Something in hops, blah, 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 blah. Again, look for your question. What is the mass in grams of this many molecules? This is where you start. This is where you end. Again, so same problem as last time. Molecules to moles to mass. Okay, 2 boats that we have to ride, the Avogadro number boat and the molecular weight boat. And we're going to end with grams. Okay, tedious, 3 sig figs. Answer has 3 sig figs. So, for this one, molecular weight, 362.5. 362.5 grams per mole for this thing. So that's what you should get. You should get 362.5 grams per mole. So we're going to start with 1.00 times 10 to the 9th molecules. Avogadro's number, 6.02 times 10 to the 23rd molecules per mole. And then in 1 mole, there's 362.5 grams. So we're going to do this out. We're going to have 3 sig figs in our answer. So we get 6.02, oddly enough. That's weird. Times 10 to the minus 13 grams. That's an amazingly small number. Okay. That's how many, that's it. That's the mass in grams of that many molecules. Hopefully that makes sense. That's the end of the set.